card is drawn. So we're just grabbing one card out of the deck. What is the probability of getting a diamond? So let's just, so that we can be very clear here, the diamond is one of 4 suits that we can choose from. So we're talking something out of this bottom row, there are 13 options. So coming back over here, we would say 13 out of the 52 cards, which reduces to 1/4 here. Okay, what is the probability that we would get a diamond and a black card? So for my friends who are not familiar with this deck of cards, refer back to this picture. The black cards are up here, the clubs and spades. Those are totally different from the diamonds down below, which are red cards. So is it possible, and means it happens at the same time, is it possible to be both a diamond and a black card? No, not possible, right? This cannot happen. These are mutually exclusive. So there is no and here. This would be 0. The probability of this happening is 0. Okay, so because these are mutually exclusive, and maybe we'll just make a little note of this here, because they're mutually exclusive, that means that if you were to draw their events, there is no overlap. So when you go to do part C, the probability of getting a diamond or a black card, we simply just add their probabilities. Probability of diamond plus probability of a black card. There's no overlap to subtract off. So probability of getting a diamond, right, that was what we did up above, that was 13 out of the 52, plus the probability of a black card, that's half your deck, so 26 out of 52. So if we come back over here, this would be 13 plus 26, and we end up with 39 out of 52, which reduces to 3/4. Okay, let's talk about part D, probability of being in the one card, both a diamond and a face card. So is it possible to be both a diamond and a face card? Face card refers to our jacks, queens, and kings. So yes, in fact, there are 3 ways that could happen. The jack of diamonds, the queen of diamonds, the king of diamonds. So we would say in this case, diamond and face card means 3 out of the 52, which does not reduce. And then finally, a diamond or a face card, these are not mutually exclusive. Right? Meaning you can be both a diamond and a face card here. So this one, the formula that we're going to use, a little different than part C, is the probability of being a diamond plus the probability of being a black card, or sorry, face card, minus the probability of being both, right? We've got to subtract off the overlap because we would have counted them twice. So the probability of being a diamond, this was 13 out of 52, plus the probability of being a face card, coming back over here, that's 12 total face cards, right? So here's your diamond, here's your face cards, and then you can probably see down here in this corner, we've counted these 3 twice. We've got to subtract off the 3 of them. So plus the 12 out of 52 minus the 3 out of 52 for probability being both a diamond and a face card. So adding this all together, our numerators, we get 25 minus 3, which is 22 out of 52, which everything reduces down by 2s then, so 11 out of 26. Okay, so in number 5, things are going to get a little different because now we're talking that it's not just a single card. We're actually going to draw a card, set it down, and then not replace it, and then draw another card. So this is 2 events occurring. 2 events. So what's the probability that I'm going to get a diamond first, set it down, and then get a black card? Well, the probability of getting a diamond is 13 out of 52. And then, so now I have 1 less card in the deck, and then, and means multiply. So I'm going to multiply by getting a black card. Well, a diamond is different than a black card. So if presumably there's a diamond laying on the desk over here, then there's still 26 remaining black cards in the deck out of the 51 remaining cards. So it's probably easier to reduce this guy first to 1/4 times the 26 over 51. You can then also cross cancel the 26 and the 4, so this becomes 2 and 13, just to make things a little bit easier on ourselves. So this would be 13 over 2 times 51 would be 102. Okay, part B and part C, these are our conditional probabilities. So remember, this little vertical line here means given. Okay, so in our first one, part B, we want to find the probability of getting a diamond given that the black card was drawn first and set down on the desk somewhere. So if a black card has already been drawn and set down, then there's still 13 diamonds left in the deck, but the one black card is sitting on the desk somewhere, so I've only got 13 out of 51 total cards, not 52. And this does not reduce. What if we switch the order? What if we are finding the probability of drawing a black card given that a diamond has already been drawn in that first draw and set down on the desk? So with knowledge that there's a diamond sitting on the desk, I only have 51 cards left in the deck. What's the probability of getting a black card? It would be 26 out of the 51. Okay, let's move on to number 6. So a box of chocolates contains 4 dark chocolates, 5 caramels, 3 chocolate mints, 2 cut chocolates with coconut, and 6 almond chocolates. So I tend to go to a picture for these, my friends. So I would think to myself, okay, so here's our box of chocolates, and I tend to take the time to organize it this way. So here's our 4 dark chocolates. So there's D for dark. Okay. We also have 5 caramels. 1, 2, 3, 4, 5 caramels. Okay. We have 3 chocolate mints. So let's do 1, 2, 3 for M. We have 2 chocolates with coconut. So let's do 1, 2. We'll do CO here for coconut. And then we've got 6 almond chocolates. So let's do 1, 2, 3, 4, 5, and 6, and those get A's. Okay. So if we add these all together, we have 4 plus 5 plus 3 plus 2 plus 6 is 20 total chocolates in here, right? So there's 20 chocolates in the box. What is the probability I would reach in? Presumably they're all the same looking, right? And I would draw out a chocolate mint. So again, I'm marking the mint ones with the M. What's the probability I would reach in and grab a mint? Well, there's 3 mint ones out of the 20 chocolates. So 3 20X. So then this one means with the bar on top, not a mint. What's the probability I would reach in and get not a chocolate mint? It's the other 17 out of the 20 options. Right? If 3 of them are chocolate mints, then 17 are not chocolate mints. Part C, what's the probability of randomly selecting a dark chocolate? Then I'm going to eat it. So now there's only 19 left. And then I'm going to reach in and select a chocolate with coconut. So this is a 2-eventer, which means I'm going to multiply the probabilities together. So the probability of reaching in and getting a dark chocolate is 4 out of 20. And then I'm going to reach in and get a chocolate with coconut. That's my COs down here. That's 2 out of the remaining 19. So if we want to make this easier on ourselves, let's reduce the first fraction first to make the numbers a little smaller, and then just multiply it across here. So this would be 2 over 95. Part D, what's the probability of reaching and getting a chocolate mint given, right, this is that bar again, given that 2 caramels are already gone. So the caramels are marked up here. So the 2 caramels have already been taken. So I'm down to 18 mints. What's the probability that I would reach in and just get a chocolate mint out of there? So that's 3 out of the remaining 18 mints. Remember, the conditional probability is a 1-event scenario. Just the probability of getting a chocolate mint, given the knowledge that 2 caramels are already gone. So 3 18ths reduces to 1/6 here. Okay, last one on this page, number 7. A bag contains 9 gold marbles. Let's see if we can actually do this here. 9 gold marbles. So here's our bag. We've got 9 gold marbles labeled 1 to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And in that same bag, you've got 6 blue marbles, and those are labeled 10 to 15. So 1, 2, 3, 4, 5, and 6. So 10, 11, 12, 13, 14, and 15. Okay, what is the probability if I'm drawing 1 marble? So this is a 1 event. If I reach into this bag, and I reach in and get a gold and an odd. So again, and means the overlap. It has to be both gold and odd in that 1 marble. So if we go through, maybe just in star, here's all of our odd marbles. So if you count up the number of stars, it looks like we have 1, 2, 3, 4, 5, 6, 7, 8 odd numbered marbles. What's the probability that I have both gold and odd? Well, there are 5 starred gold marbles out of the 15 total marbles in the bag. So this would be 1/3. What's the probability of getting a gold marble or an odd marble? Again, these are not mutually exclusive. So or means I'm going to add the probability of gold plus the probability of odd minus the probability of both. So the probability of reaching into the bag and getting a gold marble would be 9 out of the 15, plus reaching into the bag and getting an odd one, that's all the stars over here. So we said there were 8 of those out of the 15, minus the probability of being both gold and odd, were the 5 out of the 15. So if we add and subtract across here, 9 plus 8 is 17 minus 5 is 12 out of 15, which reduces to 4/5. In part C and part D, what is the probability of reaching in and getting a gold marble with the knowledge, given that it is an odd one, right? So given odd means I'm only looking at the starred marble. So out of the 8, what's the probability that we would get a gold one? Well, there are 5 starred odd gold marbles. So 5 out of the 8 odd marbles are gold. And then finally in part D, what's the probability of reaching in and getting an odd numbered marble given that it's gold? So now I'm really just sort of ignoring all the blue marbles. So I've got 9 gold marbles. So given that it's one of these 9, what's the probability that it's odd? Well, it's one of those 5 stars up there. So 5 out of 9.